Hello everyone, I'm Yuhan Wang from NTUS Lab. In this video, I'm going to introduce our paper, StyleInV. The motivation behind our video generator is twofold. Firstly, we built it upon a pre-trained style gun. Besides using it as a strong generative plier, we further make it compatible with existing style gun-based image editing techniques. Secondly, we want to apply sparse training to our pipeline. The model should allow training on clips of arbitrary lengths and avoid the motion collapse issues observed in previous works. More specifically, previous works with pre-trained style gun commonly used autoregressive models as their motion generator. For such design, motion collapse usually happens when inference length is longer than training samples. In our framework, we make the motion generator non-autoregressive. It models the mapping from image to latent, instead of relations between latent. Our motion generator is inspired by an observation that when style gun and the inversion encoder are trained on video frames, the inverted latent space is well clustered by the subject. It indicates that, first, the inversion encoder can capture informative semantic pliers like subject identity. Second, given the initial frame, a modulated inversion process may easily find the target latent with the same identity. It finally brings our motion generator design that modulates an inversion encoder. A common inversion encoder like PSP follows the ResNet architecture. They stack residual convolution blocks of decreasing resolution. To modulate it, we add add-in layers at the end of each convolution block to inject temporal styles. The temporal style consists of two parts. One is the acyclic positional encoding, another is the style gun latent of the initial frame. We can see that the modulated inversion is also an animation process of the initial frame. Thus, we need to reconstruct the initial frame when t is 0. To achieve it, we incorporate first frame aware feature into acyclic positional encoding and sparse training. For the acyclic positional encoding, it's necessary to fix the encoding of time 0 to avoid randomness in the reconstruction step. We use left-sided 1D convolution with constant padding and make the temporal noise of time 0 a learnable constant. For the sparse training, to guarantee an accurate and smooth animation, we add the initial frame into the adversarial loss, enforce initial frame reconstruction, and apply latent regularization. Our framework is compatible with existing style gun-based techniques, such as style transfer. The style gun can be fine-tuned on a tiny style dataset. We freeze the mapping network and the low-resolution synthesis blocks to align the latent space distribution. Identity loss and perceptual loss are applied between generated image with and without fine-tuning. After fine-tuning, to generate videos of different styles, we only need to replace the original image generator. The transfer is plug and play that introduces no inference latency. Here we show the qualitative results of our model and the baselines on deeper forensics dataset. Our method demonstrates superior identity preservation on human face videos. The baselines either suffer from motion collapse or identity switching. Here comes the results on Taichi dataset. Our model generates videos with long-term content consistency and lasting motion semantic. Our method remains competitive among all quantitative benchmarks. Notably, we outperform MocoGAN HD and DI-GAN trained with 16-frame clips in terms of FVD16. For the fine-tuning-based style transfer, we trained the parent model on CelebVHQ, as it has a richer identity. The videos show smooth style transfer with well-aligned face structure, identity, and expression. Our framework also supports animating a real-world image. The image is first inverted into style gun latent space with a PSP encoder, then applied in our pipeline. To conclude, StyleInV generates latent sequence of a video by modulating an inversion encoder. It features non-autoregressive training and uniquely supports the fine-tuning-based style transfer. For more information, please come to our poster session or visit the project website. Thank you.